When you look up at the night sky, you probably see a calm, quiet moon. But the truth is far more fascinating. Across our solar system, there are moons that hide entire oceans beneath thick layers of ice. Moons where powerful volcanoes erupt so violently that lava shoots hundreds of miles into space. And worlds where rain falls not as water, but as liquid methane. Some moons are so strange, they orbit their planets in the opposite direction. And the most surprising part of all, our own moon is slowly drifting away from Earth every single year. So tonight, we're going to take a quiet journey through some of the most mysterious moons in the solar system. A journey that might slowly carry you into a peaceful, drifting sleep. Imagine stepping outside late at night when the world has finally grown quiet. The streets are calm, the air feels cooler, and above you stretches a vast sky filled with distant stars. Somewhere among those quiet lights drifts a familiar companion, glowing softly as it has for countless generations. The moon seems constant, almost timeless, as if it has always watched over Earth in the same silent way. But the truth is more surprising than it first appears. Moons are not just ornaments of the night sky, they are travelers of gravity, storytellers of cosmic history, and each one carries secrets about the birth and evolution of the worlds they circle. Throughout the solar system, hundreds of moons orbit their planets in slow and graceful paths. Some are enormous, nearly the size of small planets, while others are little more than irregular chunks of rock drifting through space. A few are peaceful and frozen, unchanged for billions of years. Others are restless and active, with volcanoes, shifting ice, or mysterious oceans hidden beneath thick crusts of frozen water. These distant moons may look quiet from afar, but many of them are full of hidden energy. Our own moon is the closest and most familiar example. It has guided travelers, inspired myths, and quietly shaped life on Earth. When moonlight spills across the landscape, it is easy to believe that this glowing sphere has always been part of our planet's story. Yet even the moon has changed slowly through time, and it continues to change even now. Very gradually, year after year, the moon is drifting away from Earth. The distance increases by about 1.5 inches every year. It may sound small, but over millions of years, the change becomes enormous. Long ago, the moon would have appeared much larger in the sky than it does today. Tides would have been stronger, and the night sky brighter with reflected sunlight. This slow drifting happens because of the tides in Earth's oceans. As the moon's gravity pulls on the water, our planet's rotation transfers a small amount of energy back to the moon. That energy gently nudges it farther outward into space. At the same time, Earth's spin is slowly slowing down. Over vast stretches of time, our days are becoming longer. The change is almost impossible to notice within a single lifetime, but it reminds us that even something as familiar as the moon is part of a dynamic cosmic dance. Long before human beings existed, the moon itself was far more active than it is today. Billions of years ago, its surface was shaped by enormous volcanic eruptions. Rivers of molten rock once flowed across its landscape, filling giant basins and forming the dark plains we can still see from Earth with the naked eye. These plains, known as lunar maria, appear as dark patches across the moon's surface. Early astronomers believed they were vast oceans, though we now know they are ancient lava fields frozen in time. Even so, they remind us that the moon once experienced dramatic geological activity. But the moon's story is only the beginning. Far beyond Earth, Deeper in the solar system, there are moons that make our own look quiet by comparison. Some hide oceans beneath miles of ice. Others erupt with geysers that spray water into space. A few even have thick atmospheres and strange weather systems. And as we travel farther outward through this quiet cosmic neighborhood, we begin to realize something extraordinary. Moons are not just companions to planets. In many ways, they are worlds of their own. And as we continue drifting outward through the quiet reaches of space, it becomes clear that moons are far more diverse than we once imagined. For centuries, people believed moons were simple objects, frozen spheres circling larger planets without much story of their own. But modern exploration has revealed something far more fascinating. Many moons are complex worlds, each shaped by gravity, heat, and time in unique ways. Some of these worlds are surprisingly small, yet their shapes are anything but ordinary. Unlike large planets, which are pulled into smooth spheres by their own gravity, smaller moons often remain irregular. They can look stretched, flattened, or oddly lumpy, almost like stones worn down by countless collisions. One famous example is Phobos, the larger of Mars's two moons. Instead of being round like our own moon, Phobos resembles a rough potato drifting through space. Its surface is covered with deep grooves and enormous craters, evidence of impacts that have battered it for millions of years. From the surface of Mars, Phobos would appear to rush across the sky much faster than our moon moves above Earth. Another strange moon orbits Saturn. This tiny world called Pan has a shape that reminds many scientists of a flying saucer or even a ravioli. Around its middle is a raised ridge formed by particles from Saturn's rings slowly collecting along its equator. Over time, gravity gently shaped those particles into a thick band circling the moon. These unusual shapes tell us something important. Many small moons formed from fragments left behind during the chaotic early days of the solar system. Some were once wandering asteroids that passed too close to a planet and became trapped by its gravity. Others formed from debris created when larger objects collided and shattered. Because of these violent beginnings, smaller moons often look like broken pieces of a much larger puzzle. But while some moons remain quiet fragments of ancient collisions, others hide astonishing secrets beneath their surfaces. One of the most intriguing of these worlds orbits Jupiter. From a distance, it appears pale and smooth, covered with bright ice streaked with long reddish lines. This moon is called Europa, and scientists believe something extraordinary lies beneath its frozen crust. Deep below the ice, Europa may hold a vast ocean of liquid water. Unlike Earth's oceans, this hidden sea receives no warmth from sunlight. Instead, it stays liquid because of powerful gravitational forces. As Europa orbits Jupiter, the giant planet's gravity constantly stretches and squeezes the moon. This motion generates internal heat, warming the interior and preventing the ocean from freezing solid. The icy surface above this ocean is marked by cracks and ridges that stretch for hundreds of miles. These lines may form as the ice slowly shifts and refreezes, hinting that the ocean below is not still but constantly moving. Some scientists believe deep within Europa's hidden ocean there could be hydrothermal vents similar to those found on Earth's ocean floors. On our planet, these vents release heat and minerals that support entire ecosystems of life. If similar environments exist beneath Europa's ice, it raises an astonishing possibility. Far beneath that frozen shell, in complete darkness, there could be microscopic life quietly surviving in an alien ocean. From a distance, Europa appears silent and frozen, but beneath that calm surface may lie one of the most promising places in the solar system where life beyond Earth could exist. And Europa is only the beginning of these hidden ocean worlds.
And as we move farther from Jupiter's icy moon Europa, another remarkable world comes quietly into view. This moon circles the ringed planet Saturn, drifting through the outer solar system where sunlight grows faint and distant. Yet despite the cold darkness so far from the sun, this world is anything but lifeless in its activity. This moon is called Enceladus. At first glance, Enceladus appears small and simple. It is only about 300 miles across, far smaller than Earth's moon. Its surface gleams with bright ice that reflects sunlight almost like fresh snow. In fact, Enceladus is one of the most reflective objects in the entire solar system. If you could stand there, the ground beneath your feet would shine brilliantly under the distant sun. But beneath that bright and peaceful surface lies something extraordinary. Scientists discovered that Enceladus hides a vast ocean of liquid water beneath its icy crust. This discovery came from a spacecraft called Cassini, which spent many years studying Saturn and its moons. During its mission, Cassini detected something unusual near Enceladus's south pole. Gigantic plumes of icy particles were erupting from long cracks on the surface. These cracks, sometimes called tiger stripes, stretch across the southern region of the moon like glowing scars. From them, powerful geysers blast water vapor, tiny ice crystals, and organic molecules hundreds of miles into space. The plumes are so strong that they actually feed material into Saturn's rings, adding new particles to the vast shimmering bands surrounding the planet. Cassini even flew directly through these icy fountains. As it passed through the plumes, its instruments detected salts, water vapor, and complex organic compounds. These ingredients are incredibly important because they are similar to the building blocks associated with life on Earth. The evidence suggests that deep beneath the ice, Enceladus contains a salty ocean resting on a rocky ocean floor. There may even be hydrothermal vents there, releasing heat and minerals into the dark waters. On Earth, such vents support entire ecosystems of strange organisms that live without sunlight. Instead of relying on photosynthesis, these creatures survive using chemical energy from the vents themselves. If similar conditions exist beneath Enceladus, it raises a quiet but thrilling possibility. Life might be able to survive in that hidden ocean. What makes this even more fascinating is how easily scientists can study it. Unlike Europa's ocean, which lies beneath a thick shell of ice, Enceladus is already spraying samples of its ocean into space. A spacecraft simply has to pass through the plumes to collect material from a world buried far below the surface. In a way, Enceladus is offering its secrets freely to anyone curious enough to visit. Yet despite its hidden activity, the moon remains incredibly peaceful from a distance. It circles Saturn slowly and silently, reflecting the faint sunlight of the outer solar system. Far above its icy surface, Saturn's enormous rings stretch across the sky like glowing arcs of silver. It is easy to imagine this small world as calm and frozen forever. But beneath that bright shell lies warmth, movement, and perhaps even chemistry that could support life. And Enceladus is not the only moon where strange oceans and hidden activity exist. Farther out in the solar system, there is another moon where rivers flow, clouds drift through the sky, and rain falls across alien landscapes. But the liquid shaping that world is not water. It is something far stranger.
Far beyond the warmth of the inner planets, Saturn drifts slowly around the sun, surrounded by its elegant rings and an entire family of moons. Among them is one of the most mysterious worlds ever discovered, a place that feels strangely familiar and completely alien at the same time. This moon is called Titan. Titan is Saturn's largest moon, and it is unlike any other moon in the solar system. It is the only moon known to have a thick atmosphere, one so dense that standing on its surface would feel similar to standing beneath Earth's sky. The air there is made mostly of nitrogen, just like our own atmosphere, but mixed with methane and other complex organic molecules. Because of this thick atmosphere, Titan hides its surface beneath a hazy orange sky. For a long time, scientists could not see what lay below the clouds. It was only when spacecraft and radar instruments began studying Titan that its landscape slowly revealed itself. What they discovered was astonishing. Titan has rivers, lakes, and even vast seas spread across its surface. These bodies of liquid gather in valleys and basins, much like oceans on Earth. But the liquid filling them is not water. It is methane and ethane, hydrocarbons that remain liquid in the freezing temperatures of the outer solar system. On Titan, the entire weather cycle works with these strange liquids. Methane evaporates into the atmosphere, forms clouds, and eventually falls back down as rain. This rain carves channels into the surface, creating rivers that wind their way toward enormous lakes near the moon's poles. In many ways, Titan's landscape looks surprisingly Earth-like. If you could stand there and gaze across one of its dark seas, you might see distant shorelines stretching across the horizon. Hills and dunes would rise in the distance, shaped by gentle winds moving through the thick orange atmosphere. But the temperature would remind you that this world is far from home. Titan's surface is incredibly cold, around -180 degrees Celsius. At that temperature, water behaves like rock, frozen solid into the moon's crust. Instead of water shaping the environment, methane takes its place, flowing across the surface in slow, alien rivers. Despite the extreme cold, Titan fascinates scientists for another reason. The chemistry occurring in its atmosphere and on its surface may resemble the early chemical processes that once happened on Earth before life began. Sunlight interacting with methane and nitrogen create complex organic molecules that drift downward like tiny particles of soot. Over time, these molecules settle across Titan's surface, building up layers of organic material. Some researchers believe that beneath Titan's icy crust, there may also be a hidden ocean of liquid water mixed with ammonia. If that ocean exists, it would be buried deep beneath the frozen surface, warmed slightly by internal heat generated within the moon. This combination of organic chemistry, thick atmosphere, and possible subsurface water makes Titan one of the most intriguing places in the solar system for scientists searching for clues about how life might begin. Yet Titan is not the only moon around Saturn that challenges our imagination. Elsewhere in the solar system, there are moons that glow with powerful volcanoes, their surfaces constantly reshaped by flowing lava and explosive eruptions. These worlds are not quiet or frozen, they are alive with fire. And the most dramatic of them all orbits the giant planet Jupiter. As we leave the quiet orange skies of Titan behind, our journey moves inward again toward Jupiter, the largest planet in the solar system. Jupiter is so massive that its gravity commands an entire system of moons, each one moving through space like a miniature world with its own story. Among these moons is one of the most dramatic and restless places ever discovered. This moon is called Io. From far away, Io might appear like a bright golden marble orbiting close to Jupiter, but as spacecraft first approached it, scientists realized something astonishing. Io is the most volcanically active world in the entire solar system. Its surface is constantly reshaped by hundreds of volcanoes erupting across the landscape. Some of these eruptions are incredibly powerful. Giant fountains of molten lava can shoot hundreds of miles into space, far higher than any volcanic eruption ever seen on Earth. Rivers of glowing magma spread across the surface, cooling slowly into colorful plains of sulfur and rock. The reason for this intense activity comes from Jupiter's enormous gravity. Io is caught in a constant gravitational tug-of-war between Jupiter and two neighboring moons, Europa and Ganymede. As Io moves through its orbit, these powerful forces stretch and squeeze the moon over and over again. This process is called tidal heating. Inside Io, the constant squeezing generates enormous friction and heat. The interior becomes so hot that large portions of the moon remain molten. Pressure builds beneath the surface until it bursts out through volcanoes scattered across the crust. The result is a world that is never still. Unlike Earth's moon, which has remained mostly unchanged for billions of years, Io is constantly renewing its surface. Lava flows cover older craters, and volcanic ash spreads across wide regions. Because of this constant activity, very few impact craters remain visible. Standing on Io would be impossible for many reasons. The atmosphere is extremely thin, made mostly of sulfur dioxide gas. Temperatures swing wildly between extreme heat near lava flows and intense cold in shadowed areas. On top of that, Jupiter's powerful radiation belts constantly bombard the moon with dangerous particles. Yet, from a distance, Io is strangely beautiful. Its surface is covered with brilliant colors, yellows, reds, and blacks created by sulfur compounds spread by volcanic eruptions. These colors give the moon a mottled appearance, almost like a piece of abstract art painted across an alien landscape. Even more fascinating, some of Io's volcanic plumes are so large that they rise above the moon's horizon when viewed from space. These towering clouds of gas and dust drift outward before slowly falling back onto the surface like fiery snow. Io reminds us that moons are not always quiet companions drifting peacefully through space. Some are energetic, violent worlds where the forces of gravity and heat reshape the landscape again and again. Yet among Jupiter's many moons, there is another that stands out for a very different reason. While Io burns with volcanic fire, another nearby moon hides something entirely different. Instead of molten rock, this moon may contain a vast ocean locked beneath layers of ancient ice. And it is not just any moon, it is the largest moon in the entire solar system.
And as our quiet journey continues through Jupiter's family of moons, another immense world slowly comes into view. Compared with fiery Io and icy Europa, this moon feels calmer, older, and strangely majestic. It drifts through space with a steady presence, its surface marked by both ancient scars and mysterious patterns that hint at a long and complicated history. This moon is Ganymede. Ganymede is not only the largest moon of Jupiter, It is the largest moon in the entire solar system. In fact, it is even bigger than the planet Mercury. If Ganymede orbited the Sun directly instead of circling Jupiter, astronomers might have classified it as a planet in its own right. Yet, despite its size, Ganymede remains quietly bound to Jupiter's gravity, traveling around the giant planet once every 7 days. From space, Ganymede appears as a world of contrasts. Some regions of its surface are extremely old and dark, filled with countless craters formed by ancient impacts. These heavily scarred areas may date back billions of years to the earliest days of the solar system. But other regions look surprisingly different. Across large portions of the moon, bright grooves and long ridges stretch across the icy terrain like enormous wrinkles in the crust. These patterns suggest that long ago, Ganymede's interior was active enough to shift and reshape the surface. Something deep within the moon caused parts of the crust to fracture and slowly move, creating these sweeping lines across the landscape. Beneath this frozen surface, scientists believe Ganymede may also hide a vast ocean of liquid water. Evidence gathered by spacecraft measurements suggests that deep below the ice, a salty ocean could exist, possibly layered between sheets of frozen water. This hidden sea might be hundreds of kilometers beneath the surface, sealed away in darkness for billions of years. But what truly sets Ganymede apart from every other moon in the solar system is something invisible. Ganymede has its own magnetic field. This discovery surprised scientists when it was first detected by the Galileo spacecraft in the 1990s. A magnetic field usually forms when a world has a molten metallic core that moves and circulates beneath the surface, generating electrical currents. On Earth, this process creates the magnetic shield that protects our planet from harmful radiation. For a moon to possess its own magnetic field is extremely unusual. Ganymede's magnetic field forms a small protective bubble inside Jupiter's much larger magnetic environment. Within this region, charged particles interact with the moon's thin atmosphere of oxygen, producing faint auroras near its poles. These auroras would not look like the bright northern lights we see on Earth, but delicate glowing patterns shimmering faintly across the icy sky. The presence of a magnetic field also suggests that deep inside Ganymede lies a partially molten metallic core, quietly generating energy beneath the frozen crust. In many ways, Ganymede blurs the line between moon and planet. It has a complex interior, a possible hidden ocean, and a magnetic field of its own. Rather than being a simple satellite, it behaves more like a full world traveling alongside Jupiter. Yet, even Ganymede is not the most ancient-looking moon in Jupiter's system. Farther out, another massive moon circles the giant planet, a world that appears almost completely unchanged since the earliest days of the solar system. Its surface is covered in more craters than almost anywhere else, and beneath that ancient crust, scientists suspect something unexpected may still be quietly waiting.
Farther from Jupiter, beyond the orbits of the more active moons, another silent world drifts through the darkness. At first glance, it seems quiet, almost forgotten, as if time itself slowed down here long ago. Its surface is covered with countless craters layered upon one another, evidence of impacts that occurred over billions of years. This moon is Callisto. Among Jupiter's large moons, Callisto appears the most ancient and untouched. While moons like Io and Europa reveal signs of constant change, Callisto looks frozen in time.
Its landscape is filled with craters of every size, some so large that they overlap like ripples spreading across a pond. These craters tell the story of an incredibly old surface. For billions of years, asteroids and comets traveling through the solar system have collided with Callisto. Because the Moon has experienced very little geological activity, these impact marks have remained preserved almost exactly as they formed. The result is one of the most heavily cratered landscapes scientists have ever observed. From space, Callisto's surface appears dark and muted compared with the bright ice of Europa or Ganymede. The terrain is made mostly of ancient ice mixed with rock and dust left behind by countless collisions. In some regions, enormous circular structures stretch for hundreds of miles. One of the most famous of these is the Valhalla Basin, a gigantic impact structure surrounded by rings of fractured terrain that spread outward like waves across the icy crust. Yet, despite its ancient and battered appearance, Callisto may still hide a secret deep beneath its surface. Scientists studying measurements from spacecraft believe that far below the Moon's icy exterior, there may be a hidden ocean of salty water. This ocean would lie hundreds of kilometers underground, sealed beneath thick layers of frozen ice. Unlike Europa's ocean, which may be constantly stirred by strong tidal forces, Callisto's possible ocean is thought to be much calmer and more stable. Jupiter's gravity does not stretch Callisto as strongly, meaning the Moon's interior experiences less heating and movement. Because of this, Callisto has remained relatively quiet for most of its history. But that quiet stability could actually make it an interesting place to study. If an ocean has existed beneath Callisto's surface for billions of years, it may hold clues about how water and chemistry can survive for incredibly long periods of time in the cold outer solar system. Some scientists have even suggested that Callisto could one day serve as a safe location for future human missions exploring Jupiter's system. Unlike the inner moons, which are exposed to intense radiation from Jupiter's powerful magnetic field, Callisto lies far enough away that radiation levels are much lower. In a distant future, explorers might one day orbit this quiet world as they study the mysteries of Jupiter and its moons. For now, however, Callisto continues its slow journey around the giant planet, carrying the scars of ancient collisions and perhaps hiding a silent ocean beneath its frozen crust. Yet, our journey through the solar system's moons is far from over. Beyond Jupiter lies another giant world, surrounded by rings so vast they could stretch across millions of miles. Around this planet circle dozens of moons, each one stranger than the last. Some are shaped like spinning sponges, others are divided between bright ice and deep darkness, and one of them may even look like it was shattered into pieces and stitched back together again by gravity itself.
As our journey carries us away from Jupiter's distant moons, the solar system opens into a quieter region where another giant planet slowly circles the Sun. From afar, Saturn appears serene, wrapped in magnificent rings that stretch across space like delicate bands of light. But surrounding this graceful planet is a vast family of moons, each with a personality as strange and fascinating as any world we have visited so far. Among these moons is one of the most unusual objects in the solar system. This moon is called Hyperion. At first glance, Hyperion looks nothing like the smooth, spherical moons we often imagine. Instead, its shape is irregular and oddly distorted, almost like a sponge floating through space. Its surface is covered with deep pits and craters that give it a porous appearance, as if giant pieces of rock were carved away long ago. But Hyperion's strangest feature is not its shape. It is the way the moon rotates. Most moons spin in a predictable rhythm, turning steadily as they orbit their planets. Our own moon always shows the same face to Earth because its rotation and orbit are perfectly synchronized. Hyperion behaves very differently. Rather than spinning smoothly, Hyperion tumbles chaotically through space. Its spin is unpredictable, meaning that no one can precisely forecast how it will be oriented far into the future. One moment, a cratered side faces Saturn, and the next moment, the moon slowly flips to reveal a completely different angle. This chaotic motion happens because Hyperion is influenced by the gravitational pull of nearby moons, particularly Titan. Combined with its irregular shape, these forces prevent the moon from settling into a stable rotation. The result is a world that appears to wobble endlessly, drifting through space in a slow and unpredictable dance. Hyperion is also incredibly light for its size. Scientists believe the moon may be made of loosely packed material with large empty spaces inside. Instead of being a solid body of rock and ice, it may resemble a cosmic pile of rubble held together only by weak gravity. This porous structure explains why its surface looks so unusual. When impacts occur, the ground does not collapse into smooth craters the way it would on a dense moon. Instead, the surface absorbs the force like a sponge, leaving behind deep pits with rounded edges. Despite its strange appearance, Hyperion remains quietly suspended within Saturn's system, slowly tumbling through the darkness. But Hyperion is not the only moon around Saturn that puzzles scientists. Another nearby world appears almost as if it were painted with two completely different colors. On one side, the surface gleams bright white like freshly fallen snow. On the other half, it is as dark as charcoal. This moon is called Iapetus. From a distance, Iapetus looks like a cosmic symbol divided perfectly between light and shadow. The contrast between its two hemispheres is so dramatic that early astronomers were deeply confused when observing it through telescopes. Sometimes the moon appeared bright, while at other times it seemed strangely dim. The mystery eventually revealed itself as Iapetus continued its orbit around Saturn. One half of the moon reflects sunlight brilliantly, while the other absorbs it almost completely. Scientists believe this strange pattern may be caused by dark dust drifting through space from another moon called Phoebe. As Iapetus moves through this cloud of material, the leading side collects darker particles, slowly coating one hemisphere. Over time, sunlight warms these darker regions slightly more than the bright areas. That warmth causes ice to slowly evaporate from the dark side and settle again in the brighter regions, making the contrast even stronger. The result is one of the most visually striking moons in the solar system. Yet even Iapetus holds another strange feature that makes it even more mysterious.
Yet, the strange appearance of Iapetus does not end with its dramatic contrast of light and dark. Running along the moon's equator is one of the most unusual features ever discovered on a celestial body. Stretching across more than 1,000 kilometers is a massive ridge of mountains, rising like a narrow wall around the center of the moon. In some places, this ridge towers over 12 miles high, far taller than Mount Everest on Earth. From a distance, it almost makes Iapetus look like a giant walnut drifting through space. Scientists are still uncertain how this enormous ridge formed. One idea suggests that long ago, when the moon was still young and spinning much faster, loose material may have gathered around its equator. Over time, gravity pulled this material together into a continuous line of towering peaks. Another possibility is even more dramatic. Some researchers think Iapetus may once have possessed its own ring system, much like Saturn does today. According to this idea, particles orbiting the moon eventually fell inward, collecting along the equator and building the giant ridge that we see today. Whatever the true explanation may be, the result is extraordinary. Iapetus remains one of the most unusual moons in the solar system, a world divided between darkness and light, crowned with a mountain chain that circles the entire planet like a cosmic belt. But the mysteries of Saturn's moons do not stop there. Another nearby moon appears as though it once experienced a violent past that nearly tore it apart. This moon is Miranda. Miranda orbits the distant ice giant Uranus, and when spacecraft first photographed it, scientists were stunned by what they saw. Its surface looks like a patchwork quilt of completely different landscapes stitched together across the moon. Some regions are covered with deep canyons, while others appear smoother and younger. Massive cliffs cut across the terrain, and unusual ridges stretch across the icy plains. The most dramatic feature on Miranda is an enormous cliff called Verona Rupes. This towering drop rises nearly 20 kilometers high, making it one of the tallest known cliffs anywhere in the solar system. If someone could somehow stand at the edge and fall from the top, the descent would last several minutes before reaching the bottom. Miranda's strange and mismatched terrain has led scientists to believe that something extraordinary happened in its past. One possibility is that Miranda was once shattered by a powerful collision. The impact may have broken the moon into many pieces before gravity slowly pulled those fragments back together again. As the pieces reassembled, they created the patchwork landscape we see today. Another explanation suggests that Miranda experienced intense internal heating long ago. As the moon's interior warmed, parts of its icy crust may have melted and shifted, creating enormous cracks and cliffs across the surface. Whatever the true cause may be, Miranda appears like a survivor of some ancient cosmic disaster. Its broken landscapes and towering cliffs give the impression of a world that endured powerful forces and somehow held itself together. Yet, even these strange moons are not the only ones with unusual futures ahead. Some moons in the solar system are not destined to remain intact forever. Over immense stretches of time, gravity can slowly pull them closer and closer to the planets they orbit. And if they drift too near, the planet's gravity may eventually tear them apart completely, transforming an entire moon into a glowing ring of debris. And as we continue drifting through the quiet architecture of the solar system, we begin to see that moons are not always permanent companions. Though they may appear steady in the night sky, their futures can be surprisingly fragile. Gravity, the same force that binds moons to their planets, can also slowly pull them toward destruction. One moon in particular is quietly moving toward such a fate. This moon is Phobos, the larger of Mars's two small moons. Phobos is not large by cosmic standards. It measures only about 22 kilometers across, a tiny body compared with most major moons in the solar system. Its shape is irregular and lumpy, much like a battered asteroid that has spent millions of years drifting through space. From the surface of Mars, Phobos would look very different from our own moon. Instead of rising slowly across the sky, it would move rapidly overhead, completing an orbit around Mars in just over 7 hours. Sometimes it would rise in the west and set in the east, racing across the sky faster than any moon we see from Earth. Yet beneath this unusual motion lies a quiet but inevitable change. With each orbit, Phobos is slowly spiraling closer to Mars. The planet's gravity pulls gently but persistently on the moon, drawing it inward little by little. Scientists estimate that Phobos moves about a few centimeters closer to Mars every year. This may sound insignificant, but over millions of years, the effect becomes dramatic. In roughly 50 million years, Phobos will likely reach a point known as the Roche limit. This is the distance at which a planet's gravitational pull becomes stronger than the moon's own gravity holding it together. When that happens, Phobos may begin to break apart. Instead of remaining a solid moon, it could shatter into countless fragments of rock and dust. Those pieces would spread out into orbit around Mars, forming a thin ring system circling the planet. For a time, Mars might have its own delicate ring, similar to the ones surrounding Saturn, though far smaller and more fragile. Eventually, even that ring would not last forever. Over time, the fragments would slowly drift inward, falling into the Martian atmosphere or crashing onto the planet's surface. The entire transformation might only take a few million years, a brief moment on the cosmic timescale. Phobos already shows signs that this slow destruction has begun. Across its surface run long grooves and fractures that stretch for miles. Some scientists believe these cracks may be caused by the tidal forces of Mars gradually pulling the moon apart. Each orbit tightens the planet's grip just a little more. And yet, for now, Phobos continues its quiet journey across the Martian sky, circling its planet again and again, as it has done for countless years. Stories like this remind us that moons and rings are deeply connected. Sometimes rings gather together to form moons, and sometimes moons break apart to become rings. The solar system is constantly reshaping itself, even if those changes unfold far too slowly for human lifetimes to notice. But among all the unusual relationships between moons and planets, one partnership stands out to be truly extraordinary. Far beyond Mars, in the distant icy regions of the solar system, there is a small world that dances with its moon in a way that blurs the line between planet and companion. In that quiet place, two worlds circle each other almost as equals, locked together in a graceful gravitational embrace. Far beyond the familiar orbits of the inner planets, the solar system grows colder and quieter. Sunlight becomes faint, and the worlds that drift here are coated with ancient ice. In this distant region lies Pluto, a small dwarf planet traveling slowly around the Sun along a wide and elongated path. For many years, Pluto was thought to be a lonely world at the edge of the solar system. But scientists eventually discovered that it has several moons of its own. Among them is one that stands out in a remarkable way. This moon is called Charon. Charon is unusually large compared with the planet it orbits. In fact, it is about half the size of Pluto itself. Because of this, the two bodies share a very unique relationship, unlike most other planet-moon systems. Normally, a moon simply circles around the planet, while the planet remains nearly stationary at the center of the orbit. But in the case of Pluto and Charon, something different happens. Instead of Charon circling Pluto alone, both worlds orbit around a shared point in space known as a barycenter. What makes this especially interesting is that this center of gravity does not lie inside Pluto. It exists in empty space between the two worlds. This means Pluto and Charon actually orbit each other, like partners in a slow cosmic dance. Far beyond the familiar orbits of the inner planets, the solar system grows colder and quieter. Sunlight becomes faint, and the worlds that drift here are coated with ancient ice. In this distant region lies Pluto, a small dwarf planet traveling slowly around the Sun along a wide and elongated path. For many years, Pluto was thought to be a lonely world at the edge of the solar system. But scientists eventually discovered that it has several moons of its own. Among them is one that stands out in a remarkable way. This moon is called Charon. Charon is unusually large compared with the planet it orbits. In fact, it is about half the size of Pluto itself. Because of this, the two bodies share a very unique relationship, unlike most other planet-moon systems. Normally, a moon simply circles around the planet, while the planet remains nearly stationary at the center of the orbit. But in the case of Pluto and Charon, something different happens. Instead of Charon circling Pluto alone, both worlds orbit around a shared point in space known as a barycenter. What makes this especially interesting is that this center of gravity does not lie inside Pluto. It exists in empty space between the two worlds. This means Pluto and Charon actually orbit each other, like partners in a slow cosmic dance. If you could watch them from afar, you would see the two bodies spinning together, always facing one another as they travel around their shared center of gravity. Each takes about 6 days to complete one orbit of the other. Because they are tidally locked, the same sides of both Pluto and Charon always face each other. From the surface of Pluto, Charon would appear enormous in the sky, far larger than our moon appears from Earth. And unlike our moon, it would never rise or set. It would remain fixed in the same position in the sky forever. Charon itself is a fascinating world. Its surface is covered with a mixture of water ice and rock, giving it a grayish appearance. Huge canyons stretch across its terrain, some reaching depths of several miles. These giant fractures may have formed when its moon expanded slightly as its interior cooled and froze long ago. Near its north pole lies a mysterious dark region that scientists sometimes call Mordor Macula. This reddish area is thought to form when gases escaping from Pluto drift toward Charon and freeze onto its surface, slowly changing color through chemical reactions triggered by sunlight. This connection between Pluto and Charon shows just how closely linked the two worlds are. Some scientists even describe them as a double dwarf planet system rather than a simple planet and moon. Their partnership reminds us that gravity can create many different kinds of relationships between celestial bodies.
Sometimes one world clearly dominates another. Other times, two objects share their motion in a more balanced way. Yet Pluto and Charon are not alone in the outer solar system. Farther out, even beyond Pluto's distant orbit, there are countless icy objects drifting in a region known as the Kuiper Belt. Some of these frozen bodies are thought to be the remnants of the early solar system, leftovers from the time when planets were still forming. And occasionally, one of these wandering worlds may stray too close to a giant planet. When that happens, gravity can capture the traveler and turn it into a moon. One of Neptune's most mysterious moons may have formed in exactly that way.
Far beyond the orbit of Uranus, in the cold and distant reaches of the solar system, Neptune travels slowly around the Sun. Its deep blue color and powerful storms make it one of the most mysterious planets we know. Yet surrounding Neptune are several moons, and among them is one that behaves very differently from most others. This moon is called Triton. Triton is Neptune's largest moon, and from the moment astronomers studied its motion, they realized something unusual. Nearly all moons in the solar system orbit their planets in the same direction that the planet spins. Triton, however, does the opposite. It travels around Neptune in a backward orbit, a motion scientists call a retrograde orbit. This strange path suggests that Triton did not form alongside Neptune the way most moons do. Instead, scientists believe Triton may have once been an independent object, possibly a dwarf planet drifting through the outer solar system. Long ago, Triton may have wandered too close to Neptune. The giant planet's powerful gravity captured it, pulling the icy world into orbit. But this capture would not have been gentle. When Triton was first trapped by Neptune's gravity, its orbit was likely chaotic and unstable. The gravitational forces involved may have disrupted Neptune's earlier moon system, sending some moons crashing into the planet while others were flung out into space. Over time, Triton's orbit slowly became more stable and circular, settling into the path we observe today. From a distance, Triton appears bright and icy. Its surface is covered with frozen nitrogen, methane, and water ice that reflect sunlight with a pale glow. But despite its cold environment, Triton is not completely quiet. When the Voyager 2 spacecraft passed by Neptune in 1989, it captured images that astonished scientists. Dark plumes of material were rising from Triton's surface. These were geysers, jets of nitrogen gas erupting through the frozen crust and spraying dark particles into the thin atmosphere. Some of these plumes reached several miles high before falling back to the ground, leaving dark streaks across the icy landscape. The eruptions are thought to be powered by sunlight warming the surface. Even though the sunlight is weak so far from the sun, it can slowly heat layers of frozen nitrogen beneath the surface. As the gas builds pressure, it eventually bursts through the ice in dramatic geysers. Triton's surface also shows relatively few craters, which suggests that parts of the moon may have been reshaped more recently than scientists once believed. But Triton's future may hold another dramatic twist. Because it orbits Neptune in the opposite direction of the planet's rotation, tidal forces are slowly affecting its path. Over extremely long periods of time, these forces may cause Triton's orbit to shrink. As the moon gradually spirals closer to Neptune, it could eventually cross the critical distance where the planet's gravity becomes overwhelming. If that happens, Triton may be torn apart.
Instead of remaining a moon, it could break into countless pieces that spread out around Neptune, forming a spectacular new ring system. This event would not occur for billions of years, but it reminds us that even large moons can face uncertain destinies. For now, Triton continues its quiet orbit around Neptune, carrying the signs of a dramatic past and a distant, uncertain future. Yet, even Triton is only one example of how unusual moons can be. Elsewhere in the solar system, scientists have discovered another surprising feature shared by many moons. Hidden beneath frozen surfaces, entire oceans may exist in darkness, warmed not by sunlight, but gravity itself.
As our journey continues through the quiet reaches of the solar system, a remarkable pattern begins to appear. Many moons, even those far from the warmth of the sun, seem to share a surprising secret hidden beneath their frozen surfaces. Deep below layers of ice, there may be vast oceans of liquid water. At first, this idea might seem impossible. In the distant outer solar system, temperatures are incredibly cold. Sunlight is weak, and any exposed water would freeze solid almost instantly. Yet, scientists have discovered that many moons possess a hidden source of heat. This heat comes from gravity itself. When a moon orbits close to a large planet, the powerful pull of gravity constantly stretches and squeezes the moon's interior. As the moon moves along its slightly elliptical orbit, the strength of this pull changes slightly, creating internal friction within the moon's rocky core and icy layers. This process is known as tidal heating. Although the movement is small, the energy produced by this repeated stretching can generate significant warmth deep inside the moon. Over long periods of time, this heat can melt portions of the ice within the moon, creating underground oceans sealed beneath thick frozen crusts. Europa, the icy moon of Jupiter we encountered earlier, is one of the most famous examples. Scientists believe its hidden ocean may contain more than twice as much water as all of Earth's oceans combined. But Europa is not alone. Enceladus, the small moon of Saturn with its spectacular geysers, also contains a global ocean beneath its icy shell. The plumes of water vapor erupting from its south pole provide direct evidence that liquid water exists below the surface. Even larger moons like Ganymede and Callisto may hide deep oceans layered beneath miles of ice. These discoveries have completely changed the way scientists think about where life might exist beyond Earth. For a long time, researchers believed that planets needed to orbit within a special region around a star called the habitable zone, where temperatures allow liquid water to exist on the surface. But ocean moons show that water can remain liquid even far outside that zone. Instead of sunlight, the energy keeping these oceans warm comes from the steady pull of gravity. If these oceans contain the right combination of minerals, heat, and chemical reactions, they could provide environments where simple forms of life might survive. On Earth, some of the most unusual organisms live near hydrothermal vents deep in the ocean. These creatures thrive in darkness, relying on chemical energy released from the planet's interior rather than sunlight. If similar vents exist on the ocean floors of moons like Europa or Enceladus, they might create comparable environments where microscopic life could exist. For now, scientists continue to study these distant moons with telescopes and spacecraft, searching for clues about the hidden oceans beneath their icy shells. Future missions may even send robotic probes to explore these alien seas directly, drilling through thick layers of ice to reach the water below.
Such missions could answer one of the most profound questions humanity has ever asked. Are we alone in the universe? Yet while many moons hide oceans beneath frozen crusts, others reveal their activity more openly. Some moons tremble with mysterious internal movements. Others hold traces of ancient atmospheres that once surrounded them long ago. And even our own moon, the familiar companion shining in Earth's night sky, still carries secrets quietly hidden within its dusty surface.
As we return our attention closer to home, the quiet glow of Earth's moon begins to feel a little different. After traveling through the solar system and discovering fiery volcanoes, hidden oceans, and drifting alien seas, it is easy to forget that our own moon also holds mysteries waiting beneath its surface. For thousands of years, humans believed the moon was a silent and completely unchanging world. Its familiar craters and dark plains seemed frozen in time, untouched by movement or energy. But the more scientists studied it, the more they realized that the moon is not entirely still. Even today, the moon occasionally trembles. These subtle vibrations are known as moonquakes. During the Apollo missions, astronauts placed sensitive seismometers on the lunar surface to study the moon's interior. These instruments detected several different types of moonquakes occurring beneath the crust. Some moonquakes are caused by the gravitational pull of Earth. Just as the moon's gravity creates tides in our oceans, Earth's gravity slightly stretches the moon itself. This slow stretching builds tension in the lunar crust, which sometimes releases suddenly as small quakes. Other moonquakes happen when sunlight reaches parts of the moon that have been frozen in darkness for long periods. When the surface rapidly warms, the rocks expand and crack, sending small vibrations through the crust. But the most mysterious moonquakes come from deeper inside the moon. These deeper tremors can last for a surprisingly long time. On Earth, earthquakes usually fade quickly because water and softer materials absorb the vibrations. The moon, however, is extremely dry and rigid. Without moisture or loose sediments to absorb the energy, vibrations can echo through the lunar interior for much longer periods. A single moonquake can continue trembling for several minutes. These discoveries reveal that the moon's interior is not entirely inactive. Beneath the dusty surface lies a complex structure of rock layers, possibly including a small molten core deep inside. Although the moon no longer has the dramatic volcanic activity it once possessed billions of years ago, its interior still holds traces of the forces that shaped it long ago. Another surprising discovery involves tiny glass beads scattered across the lunar soil. These microscopic spheres formed during ancient volcanic eruptions when molten rock was blasted into space and cooled rapidly into droplets of glass. Over time, billions of these beads settled across the moon's surface. Recently, scientists studying samples from the Apollo missions discovered that many of these glass beads contain small amounts of water trapped inside them. This finding suggests that the moon's volcanic past may have involved more water than scientists once believed. Though the lunar surface appears dry and barren, traces of water may still exist hidden within its dusty regolith. In the future, these tiny glass beads might even become valuable resources for astronauts. If humans return to the moon and establish long-term bases there, water extracted from lunar soil could provide drinking water, breathable oxygen, and even fuel for rockets traveling deeper into space.
This idea transforms the moon from a barren landscape into a potential stepping stone for future exploration. Yet the moon holds one more strange detail that astronauts themselves once noticed. When Apollo astronauts returned to their lunar module after walking across the surface, the fine gray dust clinging to their suits carried an unexpected scent. Inside the spacecraft, the dust gave off an odor surprisingly similar to burnt gunpowder. It was the scent of a world shaped by billions of years of impacts and cosmic collisions. And even today, that dusty surface still hides many secrets waiting to be discovered.
As the Apollo astronauts carefully removed their helmets inside the lunar module, the strange scent of lunar dust quickly filled the small cabin. None of them had expected the moon to have any scent at all. After all, there is no air on the moon, no wind, and no atmosphere to carry scents the way it does on Earth. Yet, the fine gray dust clinging to their boots and suits carried a sharp odor that reminded them of burnt gunpowder. This surprising detail became one of the many small details but fascinating discoveries made during humanity's first visits to another world. The moon's surface is covered with a layer of material called regolith. Unlike soil on Earth, lunar regolith has never been softened by rain, wind, or biological activity. Instead, it formed through billions of years of asteroid impacts that shattered rock into extremely fine particles. Each impact blasted fragments of stone and glass across the surface, slowly grinding the landscape into powder. Because the moon has no atmosphere to slow incoming objects, even tiny meteoroids strike the surface at incredible speeds. Every collision produces more shattered debris, adding to the thick layer of dust that now blankets much of the moon. Under a microscope, these dust grains appear sharp and jagged. On Earth, natural erosion gradually smooths the edges of sand and soil particles. On the moon, however, there is nothing to wear them down. The particles remain rough and irregular, almost like tiny shards of broken glass. This makes lunar dust surprisingly abrasive. During the Apollo missions, the dust stuck to everything. It clung to the astronauts' suits, scratched equipment, and even caused minor damage to seals and mechanical parts. The astronauts quickly realized that this powdery surface was far more troublesome than anyone had expected. Despite these challenges, the missions left behind something remarkable. Along with collecting samples and photographs, astronauts placed several scientific instruments on the lunar surface. Some of these experiments continued to operate for many years after the astronauts returned to Earth. One of the most important devices placed on the moon is called a retroreflector. A retroreflector is a special type of mirror designed to reflect light directly back toward its source. Several of these mirrors were installed during the Apollo missions and are still sitting quietly on the moon today. Scientists on Earth regularly aim powerful lasers toward these reflectors. When the laser beam reaches the moon, the mirrors bounce the light straight back toward Earth. By measuring the exact time it takes for the light to return, scientists can calculate the precise distance between Earth and the moon. These measurements are incredibly accurate. They confirm that the moon continues to drift slowly away from Earth, moving a few centimeters farther into space each year. The data also helps scientists study the subtle movements of Earth's rotation and the structure of the moon's interior. Even decades after the last Apollo mission, those silent mirrors remain one of the longest-running experiments in human history.
Each pulse of laser light traveling between Earth and the Moon creates a delicate connection across nearly 400,000 kilometers of space. It is a quiet reminder that even brief visits to another world can leave lasting traces of curiosity and exploration. Yet the Moon is only one example of the many strange and fascinating companions orbiting planets throughout the solar system. Elsewhere, some moons glow with shimmering curtains of light. Others tumble unpredictably through space like drifting fragments of rock. And in certain places, the invisible power of magnetic fields paint entire worlds with silent auroras.
As our journey continues beyond the dusty plains of Earth's moon, we begin to notice another beautiful and mysterious phenomenon that appears throughout the solar system. On certain worlds far from Earth, the sky itself can glow with delicate curtains of light. These glowing displays are known as auroras. On Earth, auroras appear as shimmering waves of green, purple, and red light dancing across the polar skies. They form when charged particles from the sun collide with gases in our planet's atmosphere. Guided by Earth's magnetic field, these particles spiral toward the poles where they release energy in brilliant flashes of color. But auroras are not limited to planets. Some moons experience their own faint versions of these glowing lights. One of the most remarkable examples occurs on Ganymede, the enormous moon of Jupiter that we encountered earlier. Unlike most moons, Ganymede possesses its own magnetic field, generated deep within its interior by a slowly moving metallic core. This magnetic field forms a protective bubble around the moon. Within that invisible shield, charged particles streaming through Jupiter's powerful magnetic environment interact with Ganymede's thin atmosphere of oxygen. As these particles collide with the gas molecules, they release small bursts of energy that create faint auroral glows near the moon's poles. These auroras are far dimmer than those seen on Earth. Human eyes might struggle to notice them, but sensitive instruments aboard spacecraft can detect their subtle light. Observations of these auroras have helped scientists learn more about the hidden ocean believed to exist beneath Ganymede's icy crust. The reason is surprisingly clever. When Jupiter's powerful magnetic field shifts slightly, the auroras on Ganymede move as well. But if an electrically conductive ocean exists beneath the surface, it can partially resist those changes. By studying how the auroras respond, scientists have gathered evidence that a vast salty ocean may indeed lie deep below the frozen shell. It is a beautiful example of how invisible forces can reveal secrets hidden far beneath a world's surface. Other moons may also glow faintly with auroras under the right conditions. When they pass through strong magnetic fields or are bombarded by energetic particles, their thin atmospheres or icy surfaces can briefly sparkle with ghost-like light. These displays remind us that space is not completely dark or empty. Invisible streams of energy flow constantly through the solar system, interacting with planets and moons in ways that create subtle but beautiful phenomena. Yet magnetic fields are only one of the many invisible forces shaping these distant worlds. Gravity, working quietly over immense periods of time, continues to reshape the relationships between planets and their moons. Sometimes this influence leads to dramatic transformations that unfold over millions of years. Moons can drift outward, slowly escaping their planet's pull,
Others spiral inward, inching closer and closer until their fate becomes uncertain. And occasionally, gravity creates entirely new arrangements of celestial bodies. One of the most fascinating examples of this process occurred in the early history of our own moon. Before the moon illuminated Earth's night sky, something violent and extraordinary happened in the young solar system. A massive collision reshaped our planet forever. From that fiery event, a new world slowly formed in orbit around Earth, becoming the familiar moon we see today. Its calm appearance hides the memory of a dramatic birth that began with fire, molten rock, and one of the most powerful impacts in planetary history.
Long before the quiet moon began lighting Earth's night sky, the young solar system was a far more violent place. Planets were still forming, and enormous collisions between worlds were surprisingly common. These impacts shaped the architecture of the solar system we see today. One of the most dramatic of these events is believed to have created Earth's moon. About 4.5 billion years ago, the early Earth was still a hot and restless planet. Its surface was covered with molten rock, and the solar system around it was filled with wandering planetary fragments left over from the process of formation. Among these fragments was a young world roughly the size of Mars. Scientists call this lost planet Theia. According to the leading theory of lunar formation, Theia eventually crossed paths with the early Earth. The collision that followed was unimaginably powerful. When the two worlds struck each other, enormous amounts of molten rock and debris were blasted into space. Rather than scattering completely, much of this material remained trapped by Earth's gravity. Over time, the debris formed a glowing ring of rock orbiting our planet. Within that ring, fragments began slowly colliding and merging together. Gradually, these pieces gathered into a single growing body. That body eventually became the moon. For a long time, scientists debated whether this giant impact theory could truly explain the moon's origin. But evidence collected over decades has strongly supported the idea. One of the most important clues comes from the chemical composition of lunar rocks. Samples brought back during the Apollo missions revealed that the moon's material is strikingly similar to Earth's outer layers. The elements and isotopes found in lunar rocks closely match those found in Earth's crust. This suggests that much of the moon formed from material that once belonged to our own planet. Yet the moon also lacks certain heavy elements that would normally be found deep within a planet's core. This detail fits well with the idea that the impact mainly ejected material from the outer layers of both Earth and Theia, leaving the heavier metallic cores behind. The giant collision not only created the moon, but also reshaped Earth itself. The impact may have slightly tilted Earth's axis, helping to establish the seasons we experience today. It may also have sped up the planet's rotation, causing early Earth to spin much faster than it does now. In the early days after its formation, the moon would have looked very different from the one we see today. Because it orbited much closer to Earth, it would have appeared enormous in the sky, perhaps several times larger than its current size. The tidal forces between Earth and the young moon would have been far stronger, raising massive tides across the planet's surface. Over millions of years, the moon slowly cooled and solidified. Volcanic activity shaped its surface, creating the dark plains we still see today. Eventually, most of this internal activity faded, leaving the moon quiet and still. Yet the story of our moon reminds us that even the calmest celestial bodies may have begun with dramatic and violent origins. The peaceful glow we see at night is the final chapter of a story that began with fire and chaos. And the moon is not the only world whose surface hides dramatic differences between the side we see and the side that remained hidden for centuries. For most of human history, one entire half of the moon remained completely unknown. For thousands of years, humans gazed up at the moon and believed they knew its face completely. The same familiar patterns of dark plains and bright craters appeared night after night. Poets, astronomers, and dreamers all studied the same side of the moon, mapping its shapes and giving names to its features. Yet there was always another half of the moon that no human had ever seen. This hidden region is often called the far side of the moon. Many people mistakenly refer to it as the dark side, but that name is not entirely accurate. The far side receives just as much sunlight as the side facing Earth. The reason it remained unseen for so long is because of a phenomenon known as tidal locking. Over billions of years, gravitational interactions between Earth and the moon synchronized the moon's rotation with its orbit. As a result, the moon takes exactly the same amount of time to spin once on its axis as it does to orbit Earth. This means the same side of the moon always faces our planet. The far side remained completely hidden from human view until the age of space exploration. In 1959, the Soviet spacecraft Luna 3 became the first mission to capture images of the far side of the moon. When those photographs were transmitted back to Earth, scientists were astonished. The far side of the moon looked dramatically different from the familiar face we see from Earth. While the near side is covered with large dark plains called maria, the far side contains very few of these smooth regions. Instead, it is dominated by rugged highlands and a far greater number of impact craters. The surface appears rougher, more chaotic, and far more heavily scarred by ancient collisions. Scientists believe this difference formed very early in the moon's history. During the moon's formation, the side facing Earth may have remained warmer for a longer period of time due to heat radiating from the young planet. This extra warmth could have allowed molten rock beneath the surface to flow more easily, filling large impact basins with lava. These lava-filled basins became the dark maria we see today. The far side, however, cooled more quickly. Without the same volcanic resurfacing, its ancient craters remained preserved across the landscape. The result is almost like two completely different worlds sharing the same body. When astronauts later orbited the moon during the Apollo missions, they were among the first humans to witness the far side directly. As their spacecraft passed behind the moon, radio communication with Earth temporarily disappeared. For a few minutes during each orbit, the astronauts traveled over a landscape no one on Earth could see. Those moments were both quiet and profound. Looking down at the far side, they saw an untouched wilderness of craters stretching endlessly across the gray horizon. Even today, the far side remains largely unexplored compared with the near side. Because it never faces Earth, placing communication equipment there is more challenging for spacecraft. Yet scientists are extremely interested in this hidden region. The far side may one day host powerful radio telescopes shielded from the radio noise produced by Earth's technology. Such instruments could listen to the faint signals of the early universe more clearly than ever before. Once a mysterious and unseen half of our nearest celestial neighbor, the far side of the moon now reminds us how much of the cosmos remained hidden for most of human history.
And the deeper we explore, the more surprising these quiet worlds continue to become. Because some moons, far from remaining still, are slowly changing their orbits in ways that may eventually reshape entire planetary systems.
As we continue drifting through the quiet architecture of the solar system, it becomes clear that moons are not always stable companions forever. Though they may seem permanent from our perspective on Earth, the gravitational forces shaping their orbits are constantly at work. Sometimes those forces create gentle stability that lasts billions of years. Other times, they slowly push moons toward dramatic transformations. Gravity governs every orbit in the solar system. Planets circle the sun, moons circle planets, and smaller fragments circle wherever gravity holds them. But these motions are never perfectly fixed. Tiny changes accumulate over enormous periods of time, gradually reshaping the relationships between celestial bodies. One of the most important boundaries controlling the fate of moons is something called the Roche limit. The Roche limit is the distance at which a planet's tidal forces become stronger than the gravity holding a moon together. If a moon crosses this invisible boundary, the planet's pull can begin to tear it apart. Instead of remaining a single solid object, the moon may slowly break into countless fragments. Those fragments then spread out into orbit around the planet, forming a ring. Many scientists believe that some planetary rings may have formed exactly this way. Long ago, a moon may have drifted too close to its planet and been torn apart by tidal forces. The debris from that shattered moon could then spread out into a thin disk, eventually becoming the rings we see today. Saturn's spectacular rings are the most famous example in the solar system. These brilliant bands of ice and rock stretch across hundreds of thousands of kilometers. When sunlight reflects off their countless particles, they shine like a delicate halo surrounding the planet. Although the rings appear solid from a distance, they are actually made of billions of individual pieces. Some particles are as small as grains of sand, while others are as large as houses. Together, they orbit Saturn in an enormous, shimmering system. Scientists continue to debate exactly how Saturn's rings formed. One possibility is that they are the remnants of an ancient moon that wandered too close to the planet and was torn apart by gravity. Another idea suggests they formed from leftover material that never fully gathered into a moon during the planet's formation. Whatever their origin, the rings remind us that the boundary between moons and rings can be surprisingly thin. A moon may become a ring, and, under the right conditions, rings can also slowly gather together to form new moons. Gravity constantly reshapes these structures, even if the changes happen so slowly that they are invisible during a human lifetime. In fact, scientists have observed that small moons embedded within Saturn's rings may actually be growing. As they sweep through the ring material, particles slowly collect around them, gradually increasing their size. Over millions of years, these small clumps could potentially grow into fully formed moons. The solar system, though ancient, is still evolving. Worlds drift, collide, gather, and sometimes fall apart under the quiet influence of gravity. And among the many moons shaped by these forces, some possess features so strange that they challenge everything scientists once expected. There are moons with towering cliffs that stretch miles high. Others appear as though they were shattered and stitched back together. And some even spin in such chaotic ways that predicting their motion becomes almost impossible. As we continue this quiet journey through the solar system's many moons, we begin to notice that some of these worlds carry landscapes so strange that they almost seem unreal. Their surfaces appear fractured, reshaped, and twisted by forces that acted long ago. One moon in particular gives the impression that it was once broken apart and then slowly rebuilt. This moon is Miranda. Miranda orbits the distant ice giant Uranus, a pale blue planet that itself rotates on its side compared with most other planets. Discovered in 1948, Miranda remained a distant point of light in telescopes for many years. It was not until the Voyager 2 spacecraft flew past Uranus in 1986 that scientists finally saw its surface in detail. What they discovered was astonishing. Instead of a smooth or evenly cratered landscape, Miranda looked like a patchwork of entirely different terrains stitched together across its surface. Some regions were heavily cratered, while others appeared much younger and smoother. Gigantic ridges, deep valleys, and fractured cliffs stretched across the icy crust. It almost looked as if several completely different worlds had been fused together into one. One of Miranda's most dramatic features is an enormous cliff known as Verona Rupus. This towering wall rises nearly 20 kilometers above the surrounding terrain, making it one of the tallest known cliffs anywhere in the solar system. For comparison, Mount Everest rises about 8 kilometers above sea level on Earth. Standing at the edge of Verona Rupus would be an astonishing experience. If someone were able to fall from the top, the descent would last several minutes before reaching the bottom. The weak gravity of Miranda would make the fall feel strangely slow and silent compared with falling on Earth. Scientists believe Miranda's strange landscape may be the result of an ancient catastrophe. One possibility is that long ago, a powerful collision shattered the moon into many pieces. Gravity would then have slowly pulled those fragments back together, allowing them to reassemble into a single body. If this happened, the different pieces may have cooled and solidified in slightly different ways, creating the patchwork appearance we see today. Another theory suggests that Miranda experienced intense internal heating during its early history. As the interior warmed, parts of the icy crust may have softened and shifted, producing enormous fractures and cliffs across the surface. Either way, Miranda looks like a survivor of powerful forces that once reshaped its entire world. Yet, while Miranda shows the scars of ancient upheaval, other moons display unusual behavior in a completely different way. Instead of having strange landscapes, some moons move through space in ways that appear unpredictable. Their rotation does not follow the steady rhythm seen in most celestial bodies. One such moon drifts around Saturn, slowly tumbling through space as though it can never decide which direction to face. This unusual object is called Hyperion. Earlier in our journey, we briefly encountered this sponge-like moon with its deep craters and irregular shape. But Hyperion holds another strange quality that makes it one of the most unpredictable bodies in the solar system. Its rotation is chaotic. Unlike most moons that spin smoothly, Hyperion tumbles in a constantly changing motion influenced by the gravity of nearby moons and its own uneven shape. Because of this, its orientation cannot be predicted far into the future. Each time scientists observe Hyperion, it may present a completely different face toward Saturn. It drifts through space like a wandering fragment, slowly turning in ways that seem almost random. And yet even stranger moons still exist deeper within the solar system, where gravity, ice, and ancient impacts have created worlds unlike anything else we have seen. As we move deeper into the quiet frontier of the solar system, we begin to notice something remarkable about many of these distant moons. Though they may appear small and insignificant compared with planets, they often display features that rival entire worlds in complexity. Some of these moons possess landscapes so unusual that they seem almost impossible at first glance. One such example lies within the orbit of Saturn, a moon whose surface looks strangely divided between light and darkness. This moon is called Iapetus. From a distance, Iapetus appears like a cosmic symbol painted across space. One half of its surface reflects sunlight brightly, gleaming almost white like freshly fallen snow. The other half is incredibly dark, absorbing most of the sunlight that strikes it. The contrast between these two hemispheres is so dramatic that early astronomers were puzzled by the moon's changing brightness. When Iapetus was first observed through telescopes in the 17th century, it sometimes appeared bright and easy to see. At other times, it seemed almost invisible. The reason for this mystery lies in the moon's unusual coloration. The side of Iapetus that leads in its orbit is covered with a dark material, possibly dust drifting through space from another moon called Phoebe. As Iapetus moves along its orbit around Saturn, it slowly collects this dust on its forward-facing side. Over time, the dark particles build up and cover the surface. Once this darker material absorbs sunlight, it warms slightly compared with the brighter icy regions. That warmth causes nearby ice to slowly evaporate and migrate toward the cooler, brighter areas. This process gradually strengthens the contrast between the dark and light sides of the moon. The result is one of the most striking surfaces anywhere in the solar system. But Iapetus holds another unusual feature beyond its dramatic coloring. Running directly along the moon's equator is a massive ridge of mountains that stretches almost entirely around the world. This ridge rises many kilometers high and gives Iapetus an appearance somewhat like a giant walnut. Scientists are still uncertain how this enormous ridge formed. One theory suggests that long ago, when Iapetus rotated much faster, loose material may have gathered along the equator and gradually built up into a continuous chain of mountains. Another possibility is even more intriguing. Some researchers believe that Iapetus might once have had a small ring system of its own. Over time, particles from this ring could have slowly fallen toward the moon's surface, settling along the equator and forming the ridge. Whatever the true explanation may be, Iapetus remains one of the most unusual moons discovered so far. Yet even as we explore these strange worlds, we continue to find new surprises hidden among the smaller moons of the solar system. Some are so tiny and irregular that they resemble captured asteroids rather than traditional moons. Others appear fragile, as if they are barely held together by gravity. These small moons remind us that the solar system formed from countless collisions and fragments drifting through space. Many of them may be ancient leftovers from those chaotic early times. And occasionally, a moon can appear so oddly shaped that it challenges our expectations of what a celestial body should look like. Some resemble flying saucers. Others look like rough stones drifting through darkness. Each one carries a story written across its battered surface. And as our journey continues, we begin to discover that even the smallest moons can reveal astonishing secrets about the origins of planets and the forces that shaped the solar system itself.
As our slow journey through the solar system continues, it becomes clear that not all moons formed in the same way. Some grew beside their planets from swirling disks of dust and ice. Others were born from violent collisions that scattered fragments into orbit. But a few moons may have arrived in a completely different way. Instead of forming near their planets, they may have begun as wandering objects drifting freely through space before gravity captured them. These captured moons often have unusual shapes and strange orbits that reveal clues about their mysterious origins. One fascinating example is Mars's smaller moon, Deimos. While its companion Phobos appears battered and grooved, Deimos looks smoother and rounder, though still irregular in shape. Its surface is covered with a thick layer of loose material that softens the appearance of its craters. Many scientists believe that both Phobos and Deimos may have once been asteroids that strayed too close to Mars and became trapped by the planet's gravity. If that idea is correct, these moons are not truly children of Mars at all. They are ancient travelers captured during the chaotic early days of the solar system. Captured moons can also be found around the giant planets. Some of Jupiter's outer moons follow highly tilted and elongated orbits very different from the orderly paths of its larger moons like Io, Europa, Ganymede, and Callisto. These odd orbits strongly suggest that the objects were once independent bodies wandering through space. Over time, Jupiter's powerful gravity pulled them into orbit. Many of these captured moons are small, irregular, and heavily cratered. Their shapes resemble rough stones rather than smooth spheres, showing that their gravity was never strong enough to pull them into a round form. Yet even though they are small, these captured worlds help scientists understand how the solar system evolved. They are relics of the ancient debris that once filled the region between the forming planets. By studying their composition and motion, researchers can learn more about the materials that existed when the solar system was still young. Some of these moons may even contain information about distant regions far beyond the planets where they now reside. But among all the moons scattered throughout the solar system, there is another category that fascinates scientists even more. These are moons whose surfaces appear calm and frozen, yet show subtle signs that their interiors may still be active. Instead of towering volcanoes or erupting geysers, these worlds change in quieter ways. Their crusts shift slowly over time. Their icy shells crack and refreeze, and beneath those frozen layers, entire oceans may continue to exist in darkness. Scientists believe that tidal heating, the same process that powers the geysers of Enceladus and the hidden ocean of Europa, may also warm the interiors of other distant moons. Even worlds that appear completely frozen from space may hide warmth deep below their surfaces. These discoveries have completely transformed how we think about life in the universe. For centuries, Earth was believed to be the only place where oceans could exist. Now we know that oceans may be scattered across the solar system, hidden beneath the icy shells of distant moons. And if water, heat, and chemistry come together in the right balance, even the quietest of these worlds could potentially support simple forms of life. Somewhere beneath miles of ice, in darkness untouched by sunlight, alien oceans may be slowly stirring. As we continue drifting through the silent neighborhoods of the solar system, The idea of hidden oceans beneath icy worlds begins to feel less like science fiction and more like a genuine possibility. Beneath the frozen shells of several moons, vast bodies of liquid water may be quietly moving in darkness, warmed not by sunlight, but by the subtle power of gravity. Among these mysterious ocean worlds, one moon continues to fascinate scientists more than almost any other. This moon is Europa. Earlier in our journey, we briefly encountered Europa, Jupiter's bright and icy companion. From a distance, its surface appears smooth and pale, crossed by a network of reddish cracks that stretch for thousands of kilometers across the frozen crust. Those long lines may be clues to what lies beneath. Europa's outer shell is believed to be made of thick ice, perhaps several kilometers deep. Beneath that frozen layer, scientists suspect a global ocean of liquid water covering the entire moon. What makes Europa particularly intriguing is the size of this hidden sea. Some estimates suggest that Europa's ocean may contain more water than all of Earth's oceans combined. Despite being far from the warmth of the sun, the ocean remains liquid because of tidal heating. As Europa travels around Jupiter, the enormous gravity of the giant planet constantly stretches and compresses the moon's interior. This repeated squeezing generates heat deep inside the moon, preventing the water beneath the ice from freezing solid. The surface of Europa provides hints that this hidden ocean may interact with the icy crust above. In many places, the ice appears fractured and shifted as though large plates have slowly moved and refrozen over time. Some regions show patterns that resemble broken sea ice drifting across Earth's polar oceans. These features suggest that the icy crust may be floating on top of liquid water. Occasionally, darker materials appear along the cracks in the ice. Scientists believe these materials could come from the ocean below, pushed upward through fractures in the crust. If this is true, Europa may occasionally exchange material between its ocean and surface. Such exchanges are extremely important for scientists studying the possibility of life. On Earth, life thrives wherever water, energy, and certain chemical elements are present. Deep in our oceans, entire ecosystems exist near hydrothermal vents where mineral-rich fluids flow from the seafloor. These environments are completely independent of sunlight. Instead of relying on photosynthesis, the organisms there survive using chemical energy released by reactions between water and rock. If similar hydrothermal vents exist on the ocean floor of Europa, they could potentially provide the ingredients needed for simple forms of life. For this reason, Europa has become one of the most important targets for future space missions. Scientists hope that one day robotic spacecraft may orbit the moon and study its icy crust in detail. Some missions may even attempt to land on the surface, searching for signs of organic molecules or chemical activity connected to the ocean below. In the distant future, more advanced probes might drill through the ice itself and explore the hidden sea beneath. If such missions succeed, they could reveal whether Europa's dark ocean contains life forms unlike anything ever discovered on Earth. For now, however, Europa remains a quiet, frozen world circling Jupiter in silence. Its smooth surface hides an ocean that may have existed for billions of years, waiting patiently beneath its icy shell. And Europa is not the only moon whose hidden waters continue to intrigue scientists exploring the mysteries of the solar system.
As our quiet journey continues among the moons of the solar system, the idea of hidden oceans beneath frozen worlds begins to feel almost common. Europa is perhaps the most famous example, but it is far from the only place where scientists suspect liquid water may exist beneath an icy shell. Another fascinating ocean world circles Saturn. This moon is Enceladus. Earlier, we glimpsed Enceladus as a bright and reflective world, its icy surface shining like fresh snow in the distant sunlight. But what truly captured the attention of scientists were the enormous plumes erupting from its south polar region. These towering geysers spray water vapor, ice particles, and organic molecules far into space. When the Cassini spacecraft flew through these plumes, its instruments detected signs that the material came from a vast ocean hidden beneath the moon's crust. This ocean is believed to be salty and in contact with a rocky seafloor, creating conditions that could allow chemical reactions similar to those supporting life on Earth. The presence of organic molecules within the plumes makes Enceladus one of the most promising places in the solar system to search for extraterrestrial life. Yet, what makes Enceladus especially remarkable is how easily scientists can study its ocean. Instead of drilling through thick layers of ice, spacecraft can simply fly through the plumes and analyze the particles directly. In a way, the moon is offering samples of its hidden ocean freely to anyone capable of reaching it. Enceladus quietly circles Saturn, but with every eruption, it sends pieces of its ocean drifting into space. These icy particles eventually spread outward and become part of Saturn's ring system, adding fresh material to the delicate bands surrounding the planet. The connection between Enceladus and Saturn's rings is a reminder that moons and rings often influence each other in surprising ways. Yet, while Enceladus reveals its ocean through spectacular geysers, another moon hides its secrets beneath a thick atmosphere. This moon is Titan. Titan is Saturn's largest moon and one of the most complex worlds in the solar system. Unlike most moons, Titan possesses a dense atmosphere filled with nitrogen and methane. Beneath this hazy orange sky lie rivers, lakes, and even seas. But these bodies of liquid are not made of water. Instead, they consist of methane and ethane, hydrocarbons that remain liquid at the extremely low temperatures found on Titan's surface. Rain falls across Titan's landscape, carving channels and valleys much like rivers on Earth. Winds shape vast fields of dark dunes across the surface. From orbit, Titan looks strangely familiar and alien at the same time. Scientists believe that Titan may also contain a hidden ocean of water mixed with ammonia deep beneath its icy crust. If this ocean exists, it would be sealed beneath many layers of ice, protected from the frigid surface temperatures. Titan's thick atmosphere and complex chemistry make it a fascinating laboratory for studying the chemical processes that may have existed on early Earth. Some researchers think that Titan's organic molecules could provide clues about how life first began on our own planet billions of years ago. Future missions may even send robotic explorers to Titan's surface to study its rivers and seas directly. These missions could reveal how weather, chemistry, and geology interact on this distant world. Yet Titan and Enceladus are only two examples of the strange diversity among the moons of Saturn. Other nearby moons carry mysteries of their own, from chaotic rotations to surfaces shaped by ancient collisions. And each new discovery continues to remind us that moons are far more than simple companions to planets. They are worlds with stories waiting to be uncovered.
As we continue drifting quietly through the outer solar system, the moons surrounding Saturn reveal an astonishing variety of shapes, surfaces, and histories. Some are smooth and icy, others heavily cratered and ancient. A few even behave in ways that make them feel almost alive with motion. One such moon is Mimas. At first glance, Mimas might appear small and unremarkable. it measures only about 400 kilometers across and orbits Saturn relatively close to the planet. But what makes Mimas instantly recognizable is a single enormous crater dominating its surface. This crater is called Herschel. Herschel stretches nearly 130 kilometers wide, covering almost a third of the Moon's entire diameter. Its central peak rises high above the crater floor, like a lonely mountain standing in the middle of a vast basin. Seen from space, this massive crater gives Mimas a striking appearance. Many people notice that it resembles a famous fictional space station from science fiction films. Though this resemblance is purely coincidental, it has made Mimas one of the most recognizable moons in the solar system. The impact that created Herschel must have been extraordinarily powerful. Scientists believe that the collision nearly shattered the Moon completely. Cracks spread across the surface from the force of the impact, suggesting that Mimas came very close to breaking apart. Yet somehow, the small moon survived. Despite its dramatic scar, Mimas appears relatively inactive today. Its surface is covered with craters, and there's little evidence of geological activity reshaping the terrain. But recent measurements have raised new questions. Some observations hint that Mimas may not be entirely frozen inside. There are subtle signs that the Moon's interior could contain a hidden ocean beneath its icy crust, much like the larger water worlds we encountered earlier. If this is true, even this small and battered moon might hold more complexity than its cratered surface suggests. Nearby, another moon of Saturn presents an entirely different mystery. This moon is called Tethys. Tethys is larger than Mimas and covered almost entirely with bright ice. One of its most remarkable features is a gigantic canyon system known as Ithaca Chasm. This immense trench stretches across nearly 3/4 of the Moon's circumference. In places, the canyon reaches several kilometers deep and dozens of kilometers wide. Scientists believe this enormous fracture may have formed when Tethys's interior froze and expanded long ago. As the internal water turned to ice, it may have pushed outward, cracking the Moon's crust like a shell splitting under pressure. The result is one of the longest canyon systems found anywhere in the solar system. Tethys also possesses a massive impact basin called Odysseus. This crater is so large that it covers much of one hemisphere of the Moon. The force of the collision that created it likely reshaped the entire Moon's structure. Yet, despite these dramatic features, Tethys remains a quiet world today, circling Saturn in silence. Together, moons like Mimas and Tethys remind us how even small celestial bodies can carry the marks of ancient catastrophes. Each crater, canyon, and fracture is a record of events that occurred billions of years ago, when the solar system was still forming and collisions were far more common than they are today. These scars remain preserved across icy surfaces that have barely changed since those early times. And as we continue exploring the moons of the outer planets, we find that some of the smallest and most fragile worlds can reveal the most fascinating clues about the solar system's distant past.
As our quiet exploration continues, one gentle realization begins to settle in. The solar system is not simply a collection of planets moving through space. It is a vast network of relationships where planets and moons influence one another in subtle and powerful ways. Among all these connections, few are as important to life on Earth as the bond between our planet and its moon. From the surface of Earth, the moon may seem like a distant and passive companion, glowing softly in the night sky. But its gravitational presence quietly shapes many of the natural rhythms that life on our planet depends on. One of the most visible effects of the moon's gravity is the movement of Earth's oceans. As the moon orbits our planet, its gravitational pull draws water toward it, creating a bulge in the oceans. This movement produces the familiar rise and fall of tides along coastlines around the world. Twice each day, tides slowly advance and retreat, reshaping shorelines and stirring the waters of shallow seas. For billions of years, these tides may have played an important role in the development of life. Early in Earth's history, the mixing of seawater in tidal pools could have concentrated chemicals and organic molecules. These environments may have provided ideal conditions for the earliest biological reactions that eventually led to living organisms. In this quiet way, the moon may have helped nurture the origins of life itself. But the moon's influence extends far beyond the oceans. Another crucial role it plays is stabilizing Earth's axial tilt. Our planet rotates at a slight angle relative to its orbit around the sun. This tilt is responsible for the changing seasons we experience each year. Without the moon's stabilizing gravitational pull, Earth's axis might wobble dramatically over long periods of time. Computer simulations suggest that without the moon, Earth's tilt could shift chaotically, swinging between extreme angles. Such changes might produce severe climate variations, making it far more difficult for stable ecosystems to develop. Instead, the moon acts like a steady partner, helping to keep Earth's tilt relatively consistent. This stability has allowed climates to remain moderate enough for life to evolve and flourish over billions of years. The moon also slowly influences the length of our days. Because of tidal interactions between Earth and the moon, our planet's rotation is gradually slowing down. Each century, Earth's day becomes just a tiny fraction of a second longer. Though this change is extremely small, it adds up over immense spans of time. Hundreds of millions of years ago, a full day on Earth lasted only about 22 hours. The moon's gentle tug has been gradually lengthening our days ever since. Meanwhile, the moon itself slowly moves farther away from Earth as part of this same gravitational exchange. It drifts outward by a few centimeters each year, continuing the slow dance that has shaped the Earth-Moon system since its violent birth billions of years ago. Looking up at the moon today, it feels constant and unchanging. Yet even now, its orbit continues to evolve, and its relationship with Earth quietly influences the rhythms of our planet. Among all the moons scattered throughout the solar system, ours may not be the largest or the most exotic, but it may be one of the most important. Without it, Earth might have become a far more unstable world, and the story of life itself might have unfolded very differently beneath a darker sky.
As our quiet journey through the moons of the solar system continues, we begin to see that these distant companions are more than frozen rocks drifting around planets. They are records of cosmic history, each surface carrying the marks of ancient impacts, hidden oceans, volcanic eruptions, and subtle gravitational dances that have unfolded for billions of years. In many ways, moons are storytellers. They preserve clues about how planets formed, how gravity shapes entire systems, and how energy can remain active deep within worlds that appear silent from afar. Some moons, like Io, reveal the intense power of tidal heating through their towering volcanoes. Others, like Europa and Enceladus, hide enormous oceans beneath frozen crusts, reminding us that water may exist in places once thought far too cold to support it. Even the smallest moons can surprise us. Irregular bodies like Pan and Atlas gather material from Saturn's rings, slowly reshaping themselves as they orbit their planet. Strange worlds like Hyperion tumble unpredictably through space, their motions influenced by gravity in ways that challenge our understanding of celestial mechanics. And moons such as Triton remind us that not every satellite formed where it now resides. Some began their existence far away before being captured by the gravity of giant planets, becoming permanent members of those planetary systems. Each of these moons adds another chapter to the story of our solar system. But perhaps the most profound lesson they offer is this: planets are not isolated worlds. They exist within complex families of moons, rings, and smaller objects that interact with one another over immense spans of time. Gravity links them together in delicate balances that can remain stable for billions of years or slowly shift toward dramatic changes. Sometimes moons drift outward, slowly escaping the pull of their planets. Other times they spiral inward, approaching the invisible boundary where tidal forces may eventually tear them apart and transform them into rings. These processes happen so slowly that they are almost impossible to notice within a human lifetime. Yet, on cosmic scales, the solar system is constantly evolving. New moons may form from ring systems, while older moons may disappear entirely as they collide with their planets or break apart under gravitational stress. Even today, these quiet transformations continue across the vast distances between planets. As scientists send spacecraft deeper into the solar system, each mission reveals new details about these distant worlds. Robotic explorers orbit moons, fly through geysers, and photograph landscapes never before seen by human eyes. Future missions may go even further. One day, probes may dive beneath the icy shells of ocean moons like Europa or Enceladus, searching for signs of life hidden in alien seas. Others may explore Titan's rivers and lakes of methane, studying the strange chemistry of a world that resembles a colder, more mysterious version of Earth. Each discovery brings us closer to understanding how planetary systems form and how life might arise in unexpected places. The moons of our solar system are no longer just distant points of light in the night sky. They are worlds, and as we continue learning about them, they quietly expand our sense of what is possible in the universe. Because somewhere beyond the familiar glow of our own moon, countless other moons drift through space, each carrying its own hidden story waiting to be discovered. As our journey through the quiet company of moons slowly approaches its final stretch, it becomes clear that these distant worlds have changed the way we understand the solar system. What once seemed like simple companions to planets have revealed themselves to be dynamic places filled with motion, mystery, and unexpected complexity. For much of human history, moons were little more than points of light. Through early telescopes, astronomers could see only faint details on a few of them. They appeared as distant spheres moving silently through space, offering few clues about what they truly were. But modern exploration has transformed that view completely. Spacecraft have flown past giant planets and their moons, capturing images of landscapes no one had ever imagined. Frozen plains cracked by shifting ice, mountains carved by ancient impacts, and geysers spraying water into space have all become part of the story of these distant worlds. Each discovery has revealed that moons are far more diverse than anyone once expected. Some resemble miniature planets with complex interiors and hidden oceans. Others are irregular fragments shaped by collisions and gravitational capture. Some glow with volcanic fire. Others remain frozen and ancient, preserving the scars of the earliest days of the solar system. And among these worlds, scientists have discovered places where the ingredients for life might exist, far from the warmth of the sun. Ocean moons like Europa and Enceladus have become some of the most exciting targets for future exploration. Beneath their icy crusts, vast seas may have existed for billions of years, protected from the harsh environment of space. Within those dark oceans, chemistry may be quietly unfolding. If life can exist there, it would prove that biology is not limited to planets like Earth. It would mean that the universe may contain many hidden habitats where life could arise. Even moons that appear cold and lifeless still hold scientific value. Their surfaces preserve records of impacts, volcanic eruptions, and ancient geological processes that shaped the early solar system. By studying these frozen landscapes, scientists can reconstruct events that happened billions of years ago. Moons are like natural archives of cosmic history. And as technology continues to improve, new missions will explore these worlds in greater detail than ever before. Space agencies are already planning spacecraft that will orbit Europa, fly through the plumes of Enceladus, and land robotic explorers on the surface of Titan. Each mission will gather new clues about the environments of these distant moons. Perhaps one day humans themselves may travel to some of these worlds. Astronauts might one day stand on the icy plains of Europa or watch Saturn's rings rise above the horizon of Enceladus. They may explore Titan's alien lakes beneath its hazy orange sky. For now, these places remain far beyond our reach. Yet even from Earth, we can look up at the moon shining quietly in the night sky and remember that it is only one member of a vast family of moons scattered throughout the solar system. Each one follows its own path around its planet, guided by gravity and time. Each one carries a story that began billions of years ago. And each one reminds us that the universe is filled with worlds still waiting to be understood.
As our gentle journey through the moons of the solar system finally begins to settle into its quiet ending, it is worth pausing for a moment and simply imagining the vastness of what we have explored together. Far above our world, beyond drifting clouds and the blue glow of Earth's atmosphere, hundreds of moons continue their silent paths around distant planets. Some are large and complex worlds, nearly the size of planets themselves. Others are small, irregular fragments of rock and ice, quietly circling their planets like ancient relics left behind from the birth of the solar system. Each one moves according to the same invisible force that shapes all motion in space: gravity. This quiet force binds planets to stars, moons to planets, and even tiny grains of dust into rings that stretch across millions of kilometers. Over billions of years, gravity has choreographed an endless cosmic dance.
Moons drift slowly through space, sometimes drawing closer to their planets, sometimes moving gradually farther away. Collisions, tidal forces, and subtle interactions continue to reshape these relationships in ways that unfold far too slowly for human lifetimes to notice. Yet the evidence of these changes is written everywhere across the surfaces of these worlds. Cratered plains on ancient moons record the impacts of wandering asteroids long ago. Smooth, icy regions reveal places where hidden oceans may have warmed the crust from below. Towering volcanoes on distant moons remind us that heat and motion can still exist far from the sun. Even the quiet glow of our own moon carries the memory of a dramatic past. Born from a collision between worlds, it has spent billions of years slowly drifting outward while guiding the tides and rhythms of life on Earth. Without the moon, our planet might have been a very different place. The gentle rise and fall of the oceans, the steady tilt of Earth's axis, and perhaps even the early conditions that allowed life to begin may all be connected to this silent companion in our sky. And yet, when we look beyond our own moon, we discover an entire universe of similar companions scattered throughout the solar system. Europa hides a dark ocean beneath its icy crust. Enceladus sprays fountains of water into space. Titan carries rivers and lakes beneath a thick golden atmosphere. Io burns with hundreds of volcanoes. Triton drifts in a backward orbit, perhaps once a wandering world captured by Neptune's gravity. Each of these moons reminds us that the solar system is not a quiet collection of lifeless rocks. It is a dynamic and evolving system filled with hidden activity. And even now, new discoveries continue to reshape our understanding of these distant worlds. Future spacecraft will travel farther and observe more closely. Robotic explorers may dive beneath frozen shells or glide across alien seas of methane. One day, perhaps humans will stand on the surfaces of these moons and watch their parent planets rise above strange horizons. For now, though, the moons continue their patient orbits in the darkness. If you step outside on a clear night and look up, the familiar glow of the moon will still be there, steady and calm above the world. But now you know that beyond that quiet light lies an entire family of moons, each with its own story slowly unfolding in the vast silence of space. And somewhere out there, another moon may still be waiting for us to discover its secrets.